Okay, good morning. Characteristics of group 17 elements or halogen elements. Covalency. Fluorine shows covalency of only one. It does not shows higher covalency of 3, 5, and 7 due to absence of back-end d orbitals at similar energy levels. For example, fluorine, electronic configuration of fluorine NH2NP5. Fluorine atom in ground state. 2s2p, 3d is the higher energy level. Number of unpaired electrons, 1. So covalency, 1. However, chlorine, bromine, iodine shows covalency 1, 3, 5, and 7 due to the presence of back-end d orbitals at similar energy levels. For example, chlorine 3s2 3p5, 3d is the similar energy level. So unpaired electron 1, covalency 1. In the excited state, 3d, number of unpaired electron 3, so that covalency 3. Second excited state, number of unpaired electrons 5, covalency 5. Third excited state, number of unpaired electrons 7, covalency 7. Reactivity of group 17 elements. Reactivity of halogen decreases from chlorine to iodine. Reactivity of halogen decreases due to the following reason. Size of the halogen atom increases. Halogen-halogen bond length increases. Inter-electronic repulsion, that is lone pair repulsion decreases. Halogen-halogen bond strength increases. Enthalpy of dissociation also increases, so that reactivity decreases. Electron affinity, halogen receive electron. For example, chlorine atomic number 17 and 1 electron is added. So chloride 18 electron energy release. All halogen have a strong tendency to gain an electron and form anions, hence the electron affinity values of halogens are highly negative. Electron affinity decreases from top to bottom as the size of atoms increases. Hence, electron affinity of fluorine should be higher than the chlorine. But in fact, electron affinity of chlorine is the higher than the fluorine. That is, chlorine has highest electron affinity in periodic table. Reasons for electron affinity of chlorine is higher than fluorine. Fluorine atom has very small size. When an electron is added to fluorine atom, higher inter-electronic repulsion takes place between the valence electron of fluorine and the added electron. Due to this inter-electronic repulsion, some amount of energy is quenched. This leads to the evolution of less energy in the formation of fluoride ion from fluorine atom. However, chlorine has large atomic size, so it does not experience high inter-electronic repulsion. When an electron is added to chlorine atom, this leads to evolution of higher energy in the formation of chloride and then the fluoride ion. Fluoride ion electron affinity 333 kilojoule per mole. The small size, high inter-electronic repulsion in case of chlorine. Electron affinity 349. Large size, negligible inter-electronic repulsion. Oxidizing property. Since all halogen atoms can gain an electron and reduce into a halide ion, there are strong oxidizing agents. Oxidizing property decreases from fluorine to iodine in this series. Electron affinity of fluorine is greater than fluorine, but fluorine is stronger oxidizing agent than chlorine. Why? Electron affinity of chlorine is greater than fluorine. It means that higher energy is released when an electron is added to chlorine atom from chloride ion than in the fluoride ion. Hence, electron affinity is a thermodynamic factor which explains about the energy change. However, oxidizing property is a kinetic factor which does not depend on change in energy. Therefore, oxidizing property of an element does not depend on its electron affinity. Oxidizing property of an element depends on its relative reactivity, which is a kinetic factor. Since fluorine is more reactive than chlorine, fluorine is stronger oxidizing than chlorine.